Good morning. Welcome to the Land Grant Seminar Series 2024 fall semester. And happy birthday to our seminar series. That's see, Dr. Awal prepared this. Yeah. So as of the 23rd, we celebrate the 11th year of the seminar series that we are having in the college here. So I think, again, Dr. Awal used his analytical skills and he put some statistics about the seminar so far series. We had 239 presentations so far. And you see the basically the institution from which these presenters are. 42% of them from the college. 14% are from, or 33 presenters are from the university here. Other colleagues from other universities, research institution, state organization, federal organization, and private companies. So you can see we have a diverse contributors, and our speaker today is belongs to the last category, although also belongs to other universities as well.
Dr. Ferris, if
Yes.
I may, this is incredibly important for us, and I appreciate you and everybody. I'm requesting your help to contact Dr. Ferris and nominate or suggest a Nobel laureate in your field. And National Academy knows something from him. The best professor in your research field from the best universities. Please contact him and we'll find a way to fund them to bring to us here. Thank you.
Thank you, Dr. Memari, for that. So these are the numbers. Okay, so we would like to strengthen our opportunities to see different presenters from different institutions. So this is the rest of the semesters. Today, this is our speaker and our topic, and these are the remaining topics for the remaining of the semester. Again, as Dr. Memari mentioned, please, if you would like to submit recommend someone to present for the spring semester is not early. It's okay. I think it's better if we can have them from now is better. I think we already have like 2 or 3 already committed. So the first 2 weeks already taken. So hurry up, please. Our speaker for today, I think I'm going to ask Dr. Kidani to come and introduce our speaker, since it was he who recommended him and suggested his name. Dr. Kidani.
All right. I guess it's okay.
It's okay. You can use it.
All right.
Yeah.
Good morning, everybody. I just invited Dr. Gabe when we talk about what research is doing. I found it is very related to what we do here. So I thought that, okay, it would be good for the college to link Dr. Gabe with research scientists here. Dr. Gabe is a big brother of mine, not biologically, but he's a big brother. He's from Eritrea. We go to the same church. That's why I get to know him. He's in church, he's my mentor. So that's what the linkage started. But Dr. Gabe, his full name is Gabri Hiwot Gabra Maskal. In fact, his full name is Gabri Hiwot Nuguse Gabra Maskal, which
So you
is
share something.
yeah. So Dr. Gabe, he get his first degree in chemistry from University of Asmara and his master's degree from Addis Ababa University and his PhD from Ohio State University, and has been working in the chemical industry. He was first as an assistant professor, but later moved to the industry, and he has been working in the industry, in chemical industry mostly, related to agriculture and the oil and gas industry. His research focuses on polymer structure modification, additive evaluation, compound formulation, and the polymer characterization. He published more than 50 articles. He has a number of patents. That's why it get me more interested to invite it. When I see the volume of patents he had, that means his research is more applied, which we can use here and spread to our family. So with that short remarks, I will invite Dr.
Yes. Yeah, go to the next page.
Okay. As I said he's an assistant professor. He has been a R&D manager in several companies, including Michelin and DuPont. He's now an intellectual property manager at Corcoran American, which is in Houston, by state, and he has many awards, which is from his work. So I present and invite Dr. Gep to present his article. Thank you so much.
Thank you, and he's going to present for us an introduction to sustainable and high-performance seed coating technologies. Dr. Gabe. You can use this one. Okay.
All right, thank you.
Yeah, you're welcome.
I think it's more like good morning still. Yes, just to add to the introduction, first, thank you, Dr. Hussein, Dr. Ali, for
Yes.
the introduction. And I had a short tour through your labs, and I was very impressed about the instrumentation here. Like it was stated, I started my career as a professor. I was teaching in Ohio, but I then decided to go to the industry for many reasons, one of them being money. Now, the weather was very cold in Ohio, so I decided to come down south. That was 35 years ago. But I still miss teaching in environment like this. I really enjoy. We go everywhere and present what we can do. Basically, what we do is we work with electronic companies, agriculture companies, any company that needs binders to connect A to B. That's where our skill set is. What I'm going to present today has been patented and granted in both in Europe and in the US. So that's why I could present it. If you have any questions, please let me know. I would start first, just that's the only slide about the company. I was working with DuPont in Pasadena and Delaware with Mengtan, but some parts of DuPont have been purchased lately by a Japanese company. Nothing changed, but for us, but the investment is now with a Japanese company known as Corcoran America. It has several sites, research sites. In the Eastern area, we have at least 5, 6 different sites for research, for production, and all that. We make basically all kinds of polymers, from dental to any polymer we can design it. That's our specialty. A lot of it is the DuPont technology. So today, the challenge is it's not enough to have a good seed coating polymer that forms good films, but it has to be biodegradable, sustainable. That's what we are getting in the marketplace. We are doing, by the way, we are doing trials on this in Florida as we go, and it is currently being used by several of the large companies, including Monsanto and all that, this technology. So we are on the same baseline, I will start by defining what I mean by seed coating. We are going to talk only about the film forming, not other kinds of seed coatings. And why are we interested? Because of the growth opportunity. There is money to be made there. If not, we are not in it. What are requirements? What are the technical challenges for us? And what can we incorporate in it, in seed coating? For example, a company, Canadian company called Ripple now is using this technology to incorporate growth hormones, and they are doing the experiments in Florida. So we can basically change the polymer structure based on what you want to incorporate in the seed, is what our skill set is. And then I will give you a case study of soybeans based on essentially what we have, the patent that has already been granted, what I can disclose. So we are doing with corn and all that in Brazil now, a lot of trials going on in Arizona. So, but this has been already disclosed. So I'm not going to go through the whole slide, but our definition of seed coating is then, is just to apply a thin layer of protective material on the surface of the seed is what we do. So the main, of course, advantages are, number one, it minimizes environmental impact. For example, pesticides, now we are putting them on the seed itself, as you very well know. So there is no harm to the employee, to the environment and all that. We use a whole lot less when we do this. So we call that, as you know very well, dust off. And it improves the ease of handling of the seed. If you are going to do mechanical planting, you don't want the seed to break during tumbling and all that. And more important, when you plant it, you don't want skips, doubles, and all that. When you are using a mesh, you want it to germinate in all kinds of conditions, whether it's cold or warm weather, depending on where you are. So the polymer will change. And the good advantage, as one of our customers says, you get, say, if you are using food stimulants, they will not be used by the weed, but only by the seed. So that way you have advantage. So if you see our kind of the market we are looking currently is in 2023 was about 2 billion. Now easily estimated to go above 3 billion by 2028. So that's why we like it. Okay. So what are the requirements, basic requirements that every company places on us when they use our polymers? The first thing is it must be compatible with whatever they are trying to. Yeah, if you are using fungicide, it should not react with it, insecticide, nematicides, whatever. It has to be compatible. The seed still has to continue to be seed, so it has to exchange oxygen and carbon dioxide. That has to continue. You don't want to seal it. Moisture must reach it. So when there is some limited moisture, the film must not break. And it has to have enough mechanical strength. It has to have enough porosity. And all, as I said, minimize dust, abrasion when the seeds contact with each other. At the end, when you are ready to grow, it has to disintegrate by enough moisture. So the bonding has to be strong, but not too strong, where the seed is basically in a box. So that's the compromise of the polymer chemistry. Okay. Then what are the technical challenges for us? Every time we see this, almost daily. Some of the coatings, don't let it dry. You apply the coating and that doesn't dry. So that is not good. Some become too sticky and the seeds agglomerate. We don't want that. Some are very strong, some films, so it doesn't rupture. And the moisture control has to be right. The equilibrium has to be right there, as well as enough mechanical strength to make it from point A to point B, from the warehouse to where you plant it. What can we incorporate? What are we incorporating right now? This is what we are doing. As I said, a lot of pesticides, especially in California, where there is a lot of environmental control, Prop 65 and all that. So they don't want to put all the pesticides in Europe. So we are incorporating right on the seed. I said we use what, 100 or maybe 1,000 of what is normally used. So as you can see, the seed is there. We have two ways of doing it. We could put what we call a multi-layer. First coat the active layer is what the customer wants, and then put our films there, and then colorant. We are supposed to know which seeds are coated or not. It has to be clear. Or we could use it, what we call easy. Most people use this. Just put everything in one slurry and then coat it. Either one is feasible, but the multi-layer, of course, takes more money, more work. One thing we are very active now is incorporating also fertilizer, just to the seed is another active area. Again, there is a Canadian company that is incorporating microbes, a company called Repel. That's their interest to incorporate into the seed bacteria that fix nitrogen and all that. So growth hormones. Basically, we can modify the chemistry to where we can incorporate, basically, I wouldn't say about everything, but a lot of things now. And a lot of work is going in this area. So if you see any component of seed coats, the main components are, number one is the polymer where we come, film forming. And you want it to be flexible, so you add some plasticizers. You want it to smooth, we also add what we call talc. And lecithin is the same, more or less like a plasticizer. It has a plasticizing effect, like glycol or something like that. And then we add food approved colors just to distinguish the seed coated from the not coated. So these are the ones. But like I say, most of our work is in designing the polymer itself. So if you go through the patent literature, the following polymers are there that are used now, actively used. The first one is polyvinyl alcohol, polyvinyl acetate, acrylic resin, polyvinyl pyrrolidone. And there are what we call organic binders, like Arabica gum, soy flour, methyl cellulose, especially starches. All kinds of starches are used because people are more comfortable with it. So we have a study going on where we blend, but starch has some properties that are not adequate. So we blend the starch with our polymers to get a good film, yet it's biological, etc. So for us, one of the polymers we use is known as polyvinyl alcohol. We modify it to different things, but that's what we are using. This polyvinyl alcohol, as you can see, I'm not going to change this chemistry lecture, but as you can see the structure, it has acetate group and hydroxy group. So you can adjust by adjusting those, and you can adjust the hydrophobicity, how polar it is, depending on what we call substrate. What do you want to include? We can adjust it. It's water soluble and very superior binder. It just binds things in organics and all that with modification. And the advantage it has, it can form very thin film, strong but thin film. As I said, it's compatible with other polymers like starch. So that makes it very environmentally friendly. And now we get in a lot of business because it's biodegradable. Finally, it disappears from the. If you come in and test for the PVOH in a year or two, it will be gone. I will show you a graph that shows that it will be completely biodegraded. So that makes it even more environmentally friendly. We can modify a lot of properties by changing the functional group. We can change the water resistance, gas permeability, the strength, the mechanical adaptability. All these things we can change it. So far, some of the seeds we have worked include barley, sunflower, corn, cotton. Right now, some trial is going in Brazil, with the university in Brazil, where we are testing a lot of corn and wheat as well. We have done sugar beets, coated them. So we are testing all kinds of seeds as much as we can. So like I say, this coming to the experimental part, a case study. I will use soybean to illustrate what we did as a film former. So this was done with Monsanto company. So what they want to do was include in a seed the actives known as Acceleron. It's a blend of fungicide, insecticide, nematocide, everything blended in one. So, and then we did as a baseline just actives. They are compounds on the seed with water, that's all. And then another formula, we put our polymer, little bit, 0.75. And then to know the toxicity according to EPA and all that, you have to use a large scale. So we tripled it from 0.75 with 2.25 to see if there is any toxicity to the seed, to the environment and all that. What qualities do we measure? These are the qualities, about 6 of them we check routinely in our labs. Number one, dust off. We have an instrument that measures how much of the insecticide goes off into the air. That has to be exceptionally low. There is no criteria standard in the US, but there is an European standard, and I'll show you. So we try to stay below the European standard. Again, the seed has to germinate. At the end of the day, it doesn't germinate, the experiment is failure. So we do cold germination, warm germination, accelerated aging. The problem is, one clear problem is when you put a film on the top of the seed, it becomes sticky. That's what you are trying to do. So it can stick with the additives. But if you make it too sticky, it sticks to itself. So it doesn't flow, and the farmers don't like it. So we measure flowability. We have an instrument that does that. As well as the plantability, how easy it is to plant. Does it stick? Does it become doubles and all that? Does it skip? Appearance of the seed. And again, stickiness is with polymers, it's very hard to make it unsticky. So that's where we work. We work with the glass transition temperature, with the molecular weight, with all the properties, so it's not sticky. So these are all the 6 criteria we see whenever we apply a seed coating on any substrate, whether it's growth hormone, whether it is insecticides, whether it's fertilizer. Oh, one set of experiments we are doing, this started during the drought in California, is so we put some of our polymers in the ground and it absorbs moisture when it rains, and then slowly release the water. Even then, we have to study the biodegradability and all that. How does it hold the fertilizer? So all these are what we study. So this is if you see the dust off, as you go from left to right, it becomes cleaner and cleaner. And that's what the customer wants. We use this instrument. Basically, what you do is you put your seed in the drum, in the steel drum. And then about 40 liters of air flows through it while it's circulating in the drum. And then there is a filter here. You weigh the filter before and after. And the lower, of course, the weight on the filter, the better, the less dust. So that's the first criteria. And I was talking about the EU allowable. It's about 0.75 grams per 1,000 kernels, or about 14,000 grams of seeds. If it has to be below that, the dust off. If you use 100,000 seeds, you should have dust less than 0.75. Otherwise, the experiment is considered failure. At least you cannot sell the product in Europe then. But as soon as even without putting it in the instrument, in the dust meter, we can easily see it. You put them in a beaker, you put it upside down, you can easily see if there is pesticide, if there is any dust. If there is any dust, go back to the drawing table. So the first experiment is with our example is a polymer which only Curares sells. Basically, it's polyvinyl alcohol, which has been modified hydrophobically. We have put some hydrophobic non-polar components to it. So we knew we will work with a lot of pesticides because of the structure, from the structure properties. So what I did years ago, about 3 years ago, is we worked with a company called SGS, which is in South Carolina, in South Dakota. That's a seeding company. And we gave them the actives from Monsanto, and they tested it with and without the polymer. And if you see the bottom is the actives alone. They just put the actives on the top of the seed. And as soon as you put in our polymers, the dust decreases significantly, less than 50%. Way beyond the European recommendation. So we knew that we had something when we saw it decrease that much. So the first thing we check always is the dust off. If that fails, then everything else is useless. The other things I will not go through it, but we study it has to germinate. So we have about 3 experiments. What we call worm germination, according to the Association of Shell of Seed Analysis, is what you do is you just put the seeds, count them 100, whatever seeds they are, and you put them for 7 days at 25 degrees centigrade and see how many of them germinate. You count them physically. While the accelerated aging is the temperature, instead of 25, it goes 41 degrees for 72 hours, and then you put it as a normal temperature. This is a standard AOSA tests. So how many germinate? We should not lose the number of germinations. At least it should stay the same. The cold germination is very interesting because you put it at 10 degrees centigrade. That simulates basically warehouses up north in Canada and North US, where the warehouses are not warmed. So if you basically caught it, if it dies, then the end of the story. So that's one of the tests we do. So if you see in this experiment, again, the same model. It's where we measure the percent germination and we use our binders. So if you see actives alone, about 76, 77 of them germinated, but with our binder, almost 87, 88. So we saw that it was germinating much better. The rate of germination at cold germination was, and cold germination is even tougher because the polymer becomes more sticky because you are coming closer to the glass transition temperature, but it was much better, showed much better than the actives. So we made it sticky. Does it flow is the question. If it doesn't flow, because farmers now cannot plant by hand, they have to use a machine that plants. So if it sticks to each other, to the conveyor belt, to machines, then that's failure. So I think I have a photo of the, yes, that's what we use. Basically, all you do is just put the seed and turn it off, and it counts how long it took, the time it took, what we do. And obviously, the actives alone have the shortest time, but this is in seconds, so the difference has been judged to be negligible. That's almost practically the same. It did not slow it, and we have changed very many modified seeds, and we see it does not slow the flow rate. This is done at 25 degrees and relative humidity of 56% in this experiment. We use 300 seeds. We just put them through that funnel and just the counter counts. Again, the reason this is important is we have to make it sticky in order to hold the components, but we should not make it sticky enough to where it sticks to each other. So there is a balance there where it still flows, but it holds all the additives. So it seems like this one is reasonably successful. And do they bridge? And we saw no bridging at all with each other. So there was no reason to be concerned there. At that point, we decided to send it to the market. We also did accelerated aging. Sometimes what happens is when you increase the temperature, the film may get loose, may change, may not hold at higher temperature. So what we call accelerated temperature for us is higher temperature is 41 degrees instead of 25. not quite double, but high enough. That's what SGS does. And they keep it in cellulose peppers for 72 hours, 100 seeds, and they use the AOSA rules to count. And as you can see, Activis alone or Activis plus our polymer is almost more or less the same. When we increase the concentration, though, it shows some improvement, which means at least we didn't lose any germination rate. If anything, it's positive. As our conclusion is the coating composition did not harm or reduce germination of the seeds compared to the control Activis alone. So we are pleased with that. We also, of course, we have to do plantability using this instrument. The trick is there should not be, when you are planting, it should not be, as you know, double, singles, and all that. So they do this experiment at 25 degrees centigrade and 58. There is a certain procedure that SGS uses. And you see with they count the skips, the doublets, the misplaced, and then they calculate it to loss per acre. And as you can see, the Activis only, the loss per acre was 3, so it was much higher. But in our binders, there was no loss. There was no skips, no doublets, no misplaced. So we're kind of pleased with that binder. So the last part is, and then I can answer questions. At the end of the day, does it biodegrade? Does it disappear? Okay, it did everything. So in addition to being a good, our polymer, the proprietary polymer, in addition to being a good film former, has an excellent solubility in water. In presence of microorganisms and presence of water, it biodegrades. And what it does is it starts with this long molecule. The first thing it does is the dehydrogenase converts the hydroxy groups to 1,3 ketone. And a secondary alcohol oxidase converts it to diketon, 1,3 diketon. And finally, it breaks. This reaction continues, repeats over and over. So from a molecular weight that is literally in the thousands, you end up to basically nothing. And this has been verified by several environmental groups that this product is certified to be biodegradable. So, and these graphs are shown. For example, the yellow one is cellulose. So it's gone under certain conditions. This is a testing laboratory that we sent. In 56 days, 60 days, you can see almost 100% of it is biodegraded. And we evaluate several of our polymers. So what we learned is we can manipulate the degree of biodegradation. How many days does it take to biodegrade? We can manipulate it by changing the structures. We change the degree of hydrolysis, we change the functional group, we change the hydrophobicity. We can change a lot to manipulate it. And there are outside certifying labs which certified it to be basically like cellulose or something, like natural plants that gets biodegraded. So that's, there has to be, it is important that there has to be moisture. If you just put it in the dry, it will not do it, but there has to be some moisture for it to biodegrade. There is another one where, this is the one where we use a lot of it, and basically much cellulose in the rate of biodegradability. And we were very, very pleased with that. In 56 days, basically it's identical, it's gone. So, in summary, I try to be quick and summarize my results, but what did we achieve? We modified polyvinyl alcohol, myself and my team. This, as I said, heavily patented technology, which we are expecting to make a lot of money on it, is does almost all the criteria we put in it. It prevents dust off. In other words, protects the environment, more important, the people that work in the farm, at least by 50%. I'm doing some experiments now where we will be able to claim 75%. But in this patent, we claim it at least by 15% on soybeans, corns, and all that. The plantability, of course, showed lower loss per acre, which is positive. Worm germination shows basically no difference, but cold germination was better. We could modify the polymer where protects the seed. Now we are doing work in Brazil where we are testing it by means of X-ray to see how many of the seeds are broken, cracked, and all that. And we are seeing the preliminary results that are coming from São Paulo show that it is protecting it very well. It also has the mechanical integrity in our next patents. Yeah. Very important is, of course, the biodegradability. And as I showed you, we modified it to where this product is as biodegradable as cellulose now in its present form. And so does almost all the things we wanted to do, but still work is in progress. We are presenting our work like this everywhere. Parts of my team, as we speak, are in a meeting now to present next week, present some of this, because we think there is a strong potential for growth hormones, modification, all kinds of things be included in this field without no harm. Of course, PVOH is used in pharmaceutical, so certain concentration, so there is no harm to the human being. Anyway, you don't eat the CD plant, it doesn't matter as much. I'll be glad to answer or give more details if there are questions.
Thank you. Any questions for our speaker, Dr. Atay? Can you please pass this microphone?
Oh, yeah, sorry.
It's okay, you can have it, sorry.
For this.
We're here to serve you.
Thank you. Thank you. Is it this way? Thank
Yeah, you can speak to it.
Okay. Thank you very much, sir. I was very much interested in your presentation, although I'm not a plant scientist. I'm a food scientist. I like to eat your grains. And the question is that you were putting a colorant film around some of the seeds. What's the function of that colorant film?
Yeah, there is a lot of regulatory restrictions. For example, you are not supposed to mix something that has been coated without, there are allergies, things like that. So you have clearly to distinguish it when you sell it. So companies like DuPont, Monsanto have products that are, basically it does distinguish it, that's all. It tells you this is something that has been coated. So if you don't want it, you don't have to buy it. If you have health issues, yeah. But the colorant we use is just regular food dye.
Okay, so it's not toxic because most colorants have some toxicity.
Yeah, let me answer the question like this. It's not essential to the functioning of it.
No, I have one more. Now, the other question is that, and not under drought conditions. You said that under drought conditions, these polymers absorb water and then release it gradually. But under normal weather conditions, what is the difference in the percent germination of untreated seeds versus the ones that you have treated?
Yes.
Because my question comes from the fact that when the more processing you do to the seeds, the price of seeds go up per bushel. So it will become more expensive for the growers to buy those seeds and use them.
Yeah, that's a good question. Remember, you are, yeah, if you do coat them, there are two, I think I might have, in order to be fast, there are two things. What we are doing in California is you get the polymer, you put it under the tree. So what it does is when it rains, they had, was it 3 years, 4 years, California had very, really terrible drought. So they didn't have enough water. So what they were doing was basically put it under the tree. It absorbs the moisture when it rains or when you water it. But then we can control how slowly it releases it to the plant. So the plant doesn't absorb the polymer, doesn't do anything. It gets it water slowly. So you can cut the water consumption to basically few percentage points. That's one. So you can use it together with fertilizer. There is a company called MOS in California that's doing that. They have a commercial product on our product. That's basically what they do. They put it under the tree and it absorbs moisture. Does that make sense?
Yeah.
Not under drought conditions, under normal conditions, what's the advantage in percent germination? of
Yes.
Treated versus untreated seed.
Yeah, because if you treat it, you can add whatever you want. Pesticide, so there will not be pests. You can add growth hormones. You basically are in control, yeah? You can incorporate fertilizer just on the seed. So you can basically are under control. You can
Yeah.
make it grow faster.
Okay.
So
We're gonna go to the next question. Thank you.
Just curious, now certain polymers are affecting to the growth of rhizobium bacteria and root nodules. So I'm wondering whether these polymers will affect to the legumes you plant,
will they affect the plant?
the legumes. You know, the rhizobium bacteria is very sensitive for the polymers. So
So-
I'm just wondering.
Yes. So
if you
far,
have any data.
so far, we send these products to microbiology labs, to all testing labs, and we have not seen any effect. Remember, PVOH has been used for a long time in textile industry, where basically they size and size the textile, and it's known for years. In the Carolinas, in the US, they use a lot of this for textile.
Yeah, his question is not in the lab test. When, you know, legumes, they fix nitrogen,
I
right?
know, yeah.
Through the rhizobium. His question is, when you have this quote on legumes, does it impact their ability to fix nitrogen in the
Yes,
field?
yeah, I
Not in the
understood.
lab,
In
so,
fact, there was a point, and
Yeah.
we have not seen in the testing has not been there has
Okay.
not been even in both in the work we are doing in Florida, South Dakota. We have not seen any effect on it.
any other question? Yes, Dr. Memoli.
Well, while you are thinking about your question, colleagues, Dr. Gabi, thank you. One question I have for you is, it appears Carrera is doing really well, which, what industry representatives are supposed to present. I work at a company before. However, there are always room for improvement. As
Of
you
course.
said, you did some experimentation, and I don't know how you do by yourself, or question is, how can we explore collaborations? We have very graduate students, new cohorts, right?
Yes.
And I am here to promote industry academic research collaboration. So what are the possibilities for us to explore those?
Yes, like I said, we work with several universities, and we of course provide the product. We provide the expertise. We provide the testing. We like to work with universities. There is no question about it.
Excellent.
Yeah.
Yeah.
And we are doing it from Brazil to all the way California and South Dakota. We are working with universities.
So our professors could contact you to explore.
Exactly. Yeah, yeah. We, like I said, we provide the samples, which most of them ask the appropriate samples, so they can do their tests and whatever, and technical support as well. My team will provide the technical support.
Excellent work and excellent presentation. These coated grains, are they being used in animal feeding? Have you come across any such, are you sending your coated grains for animal feeding like corn or soybean? And does it increase the shelf life of the grains when they are stored or transported, for mycotoxins and other things?
Yeah, the big companies that produce grass, of course, use it as a fertilizer binder. Is what they use it mostly. A lot of that, and it also is used now in the applications that I'm familiar with. We sell in a lot for rooms where you keep the animals. You spray it with this product, forms a layer, film. And once the animals are out, you just wash it by hot water. It's as new, as good as new. So there are several application people are developing that I'm aware. There are things that, of course, I'm not aware. This is very competitive business, but I know we have already commercialized for this animal houses. It's just excellent application. You just spray it with a machine, and once the animals are gone out or something, you wash it. Nothing, no bacteria, no nothing.
My
It
question
covers
was
it.
on the grains, that the coated grains can be used for animal feeding.
Yeah.
Okay.
Yeah. Oh, so far, there has not been, of course, each company has to do their testing, but we have not seen any negative impact. PVOH, as I said, is used for pharmaceutical.
But I think one of the goals of the quoting is to avoid applying pesticides and herbicides, etc. So they quote the seed before seeding it so that it will germinate without need to apply pesticides or pesticides, etc. So it's not for purpose of feeding animals. It's done for seeding in the field.
Yeah.
But remember, this is a question coming from an animal scientist where there's an urgent need to coat the grains so that they would pass the stomach, rumen is called, where there are billions of bacteria and all the microbes would eat the grain. So let it pass through, the digestive system where it can release later on. That's, I think, that for animal industry, feeding industry, is a very much needed area.
It's done
That's
for
the- yeah,
pharmaceutical
yeah.
or as well.
Yeah,
Drugs.
a very good discussion. It's a very interesting discussion talking about the different purposes of this application. And I have another question here. You cannot ask question.
You can catch them in church. Back to the biodegradability, you showed that over 60 days in moist conditions, and yet you're
Yeah.
developing this for a place that's often under drought conditions. So what happens, I'm assuming when you did those studies, you had great control over moisture, and I don't know if you said how moist it was. So what happens under real life conditions where you might not have 60 days of high moisture?
It doesn't have to be high moisture, but there has to be a moisture. It does not biodegrade. The mechanism is this: it dissolves and then biodegrades. So if there is no moisture at all, then it doesn't biodegrade. Moisture, yes. If you don't have moisture, no, it does not work. Yeah, you're right.
All right, thank you, Dr. Gep. I have two questions. The first was as follow-up to Dr. Mimilis. Is there any way you can produce the same film that quotes grains for livestock feed? Because as he said, the feed goes directly to rumen. There are billions of microorganisms in the rumen. And this microorganism ferment it like they make beer. So there is a lot of gas that produces methane that affects the greenhouse gas. So in order to protect and save the grain, it has to go to another true stomach of the cow, which is abomasum, and use it as a normal digestion. So is there any plant that you can?
I have not worked on that area myself, but it would be a good area of study. Because you could coat the seed with nutrients, with everything you can.
Without being penetrated by the microorganism.
Yes.
Okay.
But
second
this is
question-
an area at present we are working in.
Okay. The second question of at the end of the day, what we are looking is for the yield, right? Did you have any research how this seed coating eventually affect yield of the product? Thank you.
Yes. This is what I was saying is being done in Florida, and increase. We don't want yet to make claims, but it increases obviously like you expected. Less weed is exceptional increase in because you are giving the necessary nutrients to every seed. The necessary, for example, this company Ripple is putting growth hormones on every seed, so they can shorten the planting time, increase the germination rate, and all that. Yes, there is a field study now being done by Ripple. It's a Canadian company. They have patented this to heck. I mean, they are working in China and Florida and all that, where the weather is reasonably good. Yes.
And I think those localized fertility gave the seed a jump start in growing fast,
Yes.
so it can shadow the weeds that are underneath it. So that's
Exactly.
basically overcompete the weeds. I'm wearing my weed scientist hat, so. Okay, any other question for our speaker? Looks like very engaging, what you call audience.
Dr. Gabby, we are faced with climate change, all kinds of changing dynamics. What's your thoughts? What are your thoughts on coating live plants as they grow up to make them more resilient and adapt to changing climate?
This is what is being done in Brazil for sugar beets. They coat them, and that's not part of my research, but that's what at least a couple of professors are doing, coating the sugar beets. Yeah. No problem.
Any other questions? If you don't, let's thank our speaker for a great presentation and a very engaging